Hello, class. Now that you've completed your assessment on the unit circle, what I need to do next with you is review with you the different ways that we can evaluate trig functions like these and solve. Because right now you have two basic methods. You have the first method I taught you with the quadrants and reference angles, and you have the unit circle. From this point forward, you get to pick how you do this. I'll never mandate that you use quadrants and reference angles or mandate that you use the unit circle again. So from now on, you choose your method. So what I'm going to do is we're going to actually do these same three problems right here. I'm going to show you three different methods. You know quadrants and reference angles, you know unit circle, and then there's a way that's kind of a combination of the two that you might prefer. So you're going to need to watch all three of these to get through the entire Edpuzzle. But after you finish this video, you get to pick the method you use from now on. So first, I'd like to review the method from section 4.4 on quadrants and reference angles. So to evaluate the sine of 7 pi over 6 using the first method I taught you, what we would do is we would sketch or think of the sketch. It's okay not to draw it on the paper. 7 pi over 6. Then we would find the reference angle. The reference angle here is pi over 6. Then we would think about or draw on the top of our page our basic 30, 60, 90. And we don't have to draw that over and over again. We could just draw it once on top of the page. We would then find whatever this function is. So in this case, sine of the reference angle. And the sine of 30 degrees will be 1/2. And that tells us that the sine of 7 pi over 6 is also going to have a value of 1/2. We just have to figure out if it should be positive or negative. And to do that, we use the quadrant that the original sketch was in. So since 7 pi over 6 lives in quadrant 3, where only tangent and cotangent would be positive, sine should be negative. And it seems like a long process, but the students who end up preferring this method, a lot of times they just draw this once on top of the page and they can do this in their head and do this in their head. But it's also okay to write it all down. Now, if you're a fan of quadrants and reference angles method, just be aware that when you go to evaluate something like the sine of pi over 2 does not have a special reference angle, so you have to use the point on the terminal side. And I don't know if you realized yet, but the point on the terminal side that we always use is the same as the point on the unit circle. So if we choose 0, 1, that's our x and our y, and our r is 1 for any of those points that we choose on the unit circle. And since sine's definition is y over r, we're going to go ahead and put 1 over 1. And the sine of pi over 2 comes out to 1. So even if you prefer the quadrants and reference angles method, if you're dealing with a quadrant angle, you are going to have to use basically the unit circle or think about the point on the terminal side of whatever the angle that is. So that's evaluating. Now, if we want to solve for theta using quadrants and reference angles, the way that we did that is we first tested or checked to see which reference angle worked, if any. So 30 and 60 won't work because there's no way you're going to get a radical 2 out of those. But if we check our 45, 45, 90, sure enough, the secant of 45 degrees will be the hypotenuse over the adjacent side, which is going to give you radical 2. And that's what we wanted. And to figure out what quadrants our angle might live in, this is where we pick the quadrants. Because secant is negative, that means cosine will be negative. And that means our angle theta could live in quadrant 2 or could live in quadrant 3. So the angle in quadrant 2 that has that pi over 4 reference angle is 3 pi over 4. And I'm only doing this in radians right now because the directions said radians. If the directions asked for degrees, I would do this in degrees as well. So 3 pi over 4 is the angle that lives in quadrant 2. Now we need the angle that lives in quadrant 3 that has that pi over 4 reference angle, which is going to be 5 pi over 4. And once again, it's okay to show all this work. It's okay just to put this on top of the paper once. It's okay if you can do pretty much all of this in your head at this point. That would be all right as well. So this is for people who like the quadrants and reference angles method. The next method we learned is using the unit circle. If you would like to stick with this method for evaluating and solving from now on, that's absolutely fine. The only thing is you will not have enough time to fill out the entire unit circle. So people who decide to stick with this method, it's usually the students who can visualize the whole thing in their heads. That's not me, but there will be a number of students in the class who find that they can do that. They can visualize the entire unit circle in their heads, and they'll stick with this method. So to evaluate the sign of 7 pi over 6, if you're someone who's going to use the unit circle method, you need to be able to visualize without filling out the entire thing or just draw a little bit. That if you look at 7 pi over 6, you're going to have an ordered pair of radical 3 over 2 negative 1/2. And since x is your cosine and y is your sine, the answer here is negative 1/2. So it is a fast method, but the reason it doesn't work for me is because I don't really have these memorized. I can't visualize that in my head. To evaluate the sine of pi over 2, if you're going to stick with the unit circle method, you're going to think of the angle pi over 2, and that point up there, 0, 1. 0 is your cosine, and 1 is your sine. And then if you're going to solve for theta using the unit circle method, you have to be able to solve something like this. So people who are going to stick with this method are going to visualize the unit circle. They're going to say, okay, radical 2 appears when I'm looking at angles like pi over 4. And if I need the reciprocal of cosine to be negative, then I can't be in quadrant 1. But maybe over here at 3 pi over 4, if I want the reciprocal of cosine to be negative, that might work. So if I go ahead and flip negative radical 2 over 2, I get negative radical 2. So 3 pi over 4 does work. And then this is not going to work. So 5 pi over 4 is not going to work because you're going to have a negative x and a negative y coordinate. But if you go over here to 7 pi over 4, and you flip, well, I just did that incorrectly. 7 pi over 4 does not work. 5 pi over 4 does work. Sorry about that. So the ordered pair at 5 pi over 4 does have a negative radical 2 over 2 for the x coordinate. And if you flip that, you get 5 pi over 4. Same answers as the other method. And just to note, this is not the only way to go about solving this equation, and you certainly don't have to show this work. If you can do that in your head, that's fine at this point. But this is just one way to go about it. And then finally, for those of you who like the unit circle but can't visualize the whole thing in your head and think you might want to use that somehow, the combo method, as I call it, is where you write down or think of the first quadrant of the unit circle, and then use all students take calculus to figure out the SIGNs as you work. So what people who like this method are going to do is you're going to write down or visualize just the first quadrant of the unit circle. And then to evaluate the sine of 7 pi over 6, you're going to sketch or think about this angle and find the reference angle. Since the reference angle is pi over 6, we're interested in this ordered pair. Sine is the y coordinate, so we're going to use 1/2. And then to figure out whether we would be positive or negative, you can think about all students take calculus. Since 7 pi over 6 lives in quadrant 3, sine should be negative. So with this combination method, you skip having to think about your special right triangles, the 30, 60, 90, and the 45, 45, 90. Instead, you just use these ordered pairs and then figure out the SIGN based on the quadrant. If you're going to use this method and you're dealing with a quadrant angle, those you can work out there because you can just do y over r or just grab the y coordinate in this case. If you're using the unit circle, r would be 1. And then if you're going to use this method for solving, what you would do, or one way to do it, because there are many ways to do this, is you would say, okay, if I want to find the thetas where secant is negative radical 2, let's first find out where secant is radical 2. That's going to involve pi over 4. That's your reference angle. Because if you flipped the radical 2 over 2, what you'll get is the radical 2. So you have the correct ratio, the correct absolute value of the ratio. Now, to make sure that secant is going to be negative, you have to pick your quadrants. When you're solving for theta, you pick the quadrants. So since secant is negative, that means cosine's negative. So we're in quadrants 2 and 3. So the angle in quadrant 2 that has that reference angle is 3 pi over 4. And the angle in quadrant 3 that has that reference angle is 5 pi over 4. Same answers as before, but a different way of thinking about it and a different way to get to the answer. Thanks for listening.